We now continue our journey looking at terms and definitions. It is important that we remember the terms that we've met because we have looked at the difference between quantitative and qualitative statistics. We are in a quantitative course in which we're going to be looking at things that can be quantified with numbers. Now then, in the last little brief lecture, we found the difference between descriptive statistics, which are used to describe, and then inferential statistics, in which we use our descriptive statistics to infer things about an area of interest that we may have. Now, in that lecture, I used some of the new terms, population and sample. What is a population? Answer: a population is any group of interest. We might be interested in the population of cars in the United Arab Emirates. We might be interested in the population of albino singing pigs. Who knows? A population is everything in any group of interest. And many populations are so large that they can never be measured, and we would then move forward, but it includes all members. We might move forward and take a portion of a population. A population is any group of interest. It includes all members. It may be large and it may be very small. It depends on the population that is of interest to us. So when you hear the term population, you think immediately about a group of interest to you. Consider this population. Very interesting population. This is the entire population of albino singing pigs in all of the world. And if you'll notice that what are there? 3, 6, 9, 12, 15 of these creatures in the entire population. Consider the population of all 10 to 20 pound rocks on Mars. Now, if we look at the population of albino singing pigs, we see that it is very small. And when we talk about the population of all 10 to 20 pound rocks on Mars, it is very large. If we had, it'd be possible for us to capture the entire population of albino singing pigs, but we could never capture the entire population of all 10 to 20 pound rocks on the planet Mars. How large is this population? Very large. This is an interesting population. This is the population of all ugly statistic teachers named Professor Waller. What is a population? A population is often called a universe of interest. Now, you're beginning to get terms. Population, a universe of interest. A universe means a complete set of all items of interest. Now, hence we have the old joke test assignment when they would say define the universe and provide 3 examples. If you're in statistics and you understand your terminology, you can define the universe and you can provide 3 examples. The universe means a complete set of all items of interest. We might have the universe of albino singing pigs. We might have the universe of all 10 to 20 pound rocks on Mars. And we might have the universe of all ugly statistics teachers named Professor Waller. Now, what is a sample? Answer: a sample is a part or a subset of a population. The sample may actually be every item in the population. Samples may be large or small. Now, generally, the sample is not every item in the population. It is a part of the population. And samples may be large or small. We may have 1,000 in our sample. We may have 1,500 in our sample. We may have 200,000 in our sample. Our sample may be small. We may have 6. We may have 5. So a lot of times when you talk about samples, you will hear large sample, small sample. And later on, we will actually define the numbers that we traditionally use to separate the two. Do you remember this population? This is the entire population of albino singing pigs. Now, we will randomly select a sample of these animals. Random means that everyone has an equal possibility of being selected. Many years ago, I taught special education. I had a little kid. He was a mess. And he came to me and said, "I'm smart." And I said, "Well, Jimmy, how do you know you're smart?" He said, "My grandma says I'm smart." So if your sample is your grandmother, who's going to give an answer that is kind of biased. That is not a random sample. Random means everyone has an equal chance of being selected. Now, we will randomly select 5 animals. There's one. We randomly select that one. We did these, but each one had an equal chance of being selected, and we did this without regard to their singing ability. They were chosen at random. Now, I want to point out to you that it is very hard to truly have a random sample. A computer has a random number generator. Even that is not truly random. It is built on an algorithm that has bias in it. But random means that we select them without regard to any predetermined characteristics, that each one has an equal chance of being able to be chosen. Now, we had the entire population of albino singing pigs, and now we have a sample from our population. Our sample was random. So we've met new words: population, every item of interest, the universe of every item of interest. Sample, a portion of a population, a subset of a population. 3 new terms to know: population, every item in a group of interest; sample, a part or subset of a population, and the subset may be the entire population, but generally it's not. Random, every item has an equal chance of being chosen. Now you continue your journey through the land of nerd. You're making progress. You're learning terms. You now know the difference between quantitative and qualitative statistics. You understand that we have descriptive statistics and inferential statistics, and we have population, sample, and you know what random means. Most of the time in statistics, we are taking a sample, describing that sample, and then using that description to explain something about the population or to infer facts about the population. You're beginning to learn the terms. Keep climbing the ladder, my friends. You've got this. I told you this is not mathematics. This is statistics. This is a totally different course. You will learn the terms, and then you will learn how to use the terms, and you will be informed in the subject of statistics. Good luck.